Hello, everyone. We are about to start our webinar, Step into the World of Microservices using Node.js. So today, I'm going to talk. I'm Daniela Matos de Carvalho. I work at YLD. I do Node.js for quite a while, 2 years and a half. I do a lot of React also, and at YLD we also do some DevOps. And we are going to have also with us Daniel from Cloud 66, a really experienced developer from them. And we decided to join forces from YLD and Cloud 66 to create this webinar. So let's get it started. In the beginning, I'm going to give a brief introduction to microservices and what services are. Going to explain the example that we created. It's quite a analytics application structure, and how to test it with Node.js, and then I'll pass to Daniel, which are going to talk about how to develop it with Docker and how to deploy it using Cloud 66. So about services. Services are organized around domains. So you can have like services for logistics, service for billing, services for accounting, and many others. For instance, also you can think about the user. How are you going to handle the user preferences and many others. So the idea of these services is that they are really easy to change, easy to replace, and this leads to create really autonomous teams that can work independently, and they can use really different programming languages if they want, different databases, and they can have really different environments depending on what fits best. If you are interested in microservices and how everything works and what are how to handle logs, how to handle errors, and so on, I would recommend taking a look at a book, Building Microservices from Sam Newman. It's quite good. So let's get it started with our example. The core idea is to create analytics. We have some clients that are sending messages to a Node.js server, and that server is going to publish this information of the events that it received. One example of an event could be the user clicking on a button, for instance, or using, creating or adding some information to a specific field. We might want to send this to our analytics application, and then the Node.js server is going to publish it to a message queue, and we can have multiple subscribers or consumers that are going to take a look at this information, and they can do several things with that information. For instance, they can save them to a database, they can communicate to external API, or they can decide other ways to handle them. One example of a message that we can send is this one. So we can have like the user ID or the information about the user and the event itself, in this case a button click, but we can have many other information, such as which browser the user is using, and so on and so forth. Basically the things that you can have in Google Analytics console. And basically this message is going to be sent to a post/analytics in our server, and the server is going to handle that message, and we have like a map inside our server that will understand if the message is a button click or a button hover. In this example, it will see, it will map that message to be an analytics.button key that is going to be published to the rabbitmq, and the subscribers are going to consume it. So we have a rabbitmq, but what is really a message queue and why do we need it? A message queue can help you to send data to an exchange, and in this case, what we have is that some consumers, some subscribers can pick that message and work on with that. There are some alternatives to rabbitmq, such as Amazon SQS, ZeroMQ, Google PubSub, and some many others. But we decided to pick rabbitmq because it's widely used, and also because it can be integrated with Cloud 66. We decided to use a message queue, also because it's a really good example when you need to process and parallelize some intensive tasks, such as image processing or send a huge amount of emails to your clients. And that's basically it. There are some notes about rabbitmq topics and keys. So where both the consumers and the producers need to be using the same topic, register using the same topic, and then the producer is going to send some queues that are going to be listened by the producers. So in this example, I have here some examples of keys that we can have in rabbitmq. And in the first example, analytics.hash means that you can have 0 or more words after the hash. Analytics.start, you need to have exactly 1 word, and so on. So you can create all the examples you'll need. In our particular case, it's quite nice if we have analytics.image, analytics.button, and the more general one that can catch everything. And our subscribers can subscribe to multiple keys. The default one is analytics.something that will grab all the keys that start with analytics. So let's take a look at our project structure. We decided to use Lerna. Lerna, if you take a look at this URL that I shared in the beginning, we have all the code here, github.com/yldio/training analytics webinar. And Lerna follows this concept of a monorepo. And the idea is that we can manage in an easy way multiple packages. So inside our packages folder, we have a publisher and a subscriber folders, and some Docker files that you can see, and some test folders. And let's take a look at the structure of the publisher itself. In the publisher, we have the index.js file that is going to be the entry for our server, the handler, and some utilities that we are going to have. So this is basically our simple HTTP server. It just has a really simple route, so we decided not to use Express or Happy. We just stick with a simple HTTP server, and we are just listening to this route /analytics when a post is sent. So this request, when it comes, the fields of the body are going to be parsed and validated, and then the handler is called. And the handler doesn't do that much for now. We don't need to handle a lot of work. We are just going to publish to the rabbitmq. It basically takes a look at the map we talked in the beginning that has the maps for the keys, and find the key that we want to share and to publish into the rabbitmq. So if it's a button, it's going to be analytics.button that is going to be sent. And we also have the code of the publisher itself. It's a singleton. It's the connection to create the connection to the rabbitmq. And here we are basically creating an exchange for a specific topic that both consumers and producers can share. And after it, we are publishing on line 31 this specific message that we are going to send, for instance, because the user clicked on a button. The subscriber code is more or less similar, so it's listening to the same topic. it is on line 26 to 29. You can see that it could subscribe to several keys, and then from line 31 to 34, it is handling the messages that are going to be received. There's also this two flags here, durable and no hack, that are quite interesting in rabbitmq. So durable means that if you have durable true, messages are not going to be lost. So if you want the messages not to be lost when something crashes, for instance, a consumer crash, you can change this to true. And no hack means no acknowledgement. And if we have it set to true, we are not going to send an acknowledgement if we receive a message. So it will be a bit faster, but in our case, it's just an analytics app. So if one message is lost, may not be a problem. Yeah, our example itself, we talked a bit about our example, and now I have some information about how to start it. And here you can see on the left side that I'm starting the rabbitmq server. In the middle left, you can see that I'm starting the publisher, and in the bottom left, I'm curling the publisher to send a message of a button click. On the right side, I have 3 subscribers, and these 3 subscribers, the first one is listening to every analytics message. The middle one, just to analytics.banana.something, and the bottom one to analytics.image. So in this case, only the first subscriber received that message. In the second example, we have a different type of event. It's an image hover. So on the right side, you can see that both the top right and the bottom right received this message because they were subscribing to images or to all the events. About testing. So we used Istanbul here. Istanbul is really nice to create HTML reports for your code. It's nice to have an overview of your unit tests. We also used Lab. It's a test runner created by the Happy.js community. And in this case, we also have a semi-standard validation. We don't need it at all. We could remove the semi-standard validation to another script, to, for instance, a linting script, and do npm lint. But for now, to keep it simple, and for this example, we added it here, and we are running basically our tests to the test folder. So this is an example of the output that the HTML output that is created by the reports. So you can see that we don't have 100% coverage, for instance, for the analytics handler file. And we can also take a look at the code itself and understand why. So if I open it, you can see on line 8 and 14 that we are not testing those callbacks when there is an error. And if you take a look at the code itself of the test, you can see that we are using Lab, the test runner, and code, which is an assertion library, similar to Chai. And you can see from that the test is only testing the publishing of a message that we are simulating here. So we are not testing the callbacks. A way to solve this is to use Sign.js, for instance, and we can create mocks or stubs to the publisher instance, and then validate this and test this. So that's all from my side. I'll pass to Daniel.
Yeah, hi. So I'm gonna switch the screens. I'll hold the slide before then I can just switch my screens and I'll start my presentation. Let me just change the screens now. Oh, here we go. So thanks, Daniela, for the explanation of the Node example. So the second half of this presentation, we're going to look at deployment and developing Node projects with microservices using Docker. And so first of all, developing Node.js services with containers. So I'm just doing a small introduction what containers are. Just probably everybody's already familiar with containers, I hope. But there's a distinction between virtual machines and containers. So virtual machine isolates an operating system and the resources it can use, and containers isolate the process and the resources it can use. And the nice thing with containers is that you can run different node processes isolated from each other, and also you can mix match technology. So if you want to run Node or Java or Go together, you can. So basically, what this is that on Linux you have a very clever kernel stuff, and on top of it you run a container, which is basically an isolated process. And to tell what you run in a container, you create this thing called a Docker file. And basically, Docker file is your recipe, what you need to run your microservice, which is in this case a Node application. So basically, a Docker file looks like this: basic steps from you start with a base image. This is from a Node project. It's probably a Node base image with the version you want. You run some updates to set up. Maybe you want to install some Node packages you need during compilation. Then you copy the source code. Then you run maybe an npm build. Maybe you have to pre-compile some assets. You do some cleanup, and of course you specify how to run this container. So developing Node.js services with containers. So we're already saying containers isolate the process, and containers give you an isolated development, test, and production environment, which is quite nice. So on your development box, you can just spin the whole system, not only in one microservice, but also your database, or maybe you wrote a service in Go which has to work with Node. You can. So basically, you can spin up the whole microservice architecture on your local box before you send it to testing or production environment. So you can also do like integration tests on your local machine. And Docker Compose is basically a tool to create compositions of your service and backends, so you can mix technology. And Docker Compose is something which is really handy to do some Node microservice development on your local machine. So if you look at the source code, I already put in the URL in the live chat. So we have a live chat next to the live stream. So if you have any questions, just pop in your questions, and in about 10 minutes when we end this presentation, we'll answer those questions. So if you look at the source code, in the root directory of the GitHub, of the Git repo, you find the Docker Compose. And basically you see the different services Daniela created. So you have the publisher, the subscriber, and the rabbitmq. And if you look at line 6, you can see that we specify how to build this publisher. So we provide them with a Docker file. So when you run Docker Compose up, it will build those images, which is basically the blueprint of your service, and then start it. And your Docker file is a description what kind of package you need to run that publisher. Also, you can see that we specify the ports. So basically, a container runs isolated, and if it runs to a port, you have to expose that port to the outside world. So in this case, we're saying so the publisher is running on port 3000, but we map it to port 8080. So if you hit your browser on port localhost 8080, you hit this endpoint of the publisher. You can see that we link with rabbitmq. So this tells us that we the nice thing about microservices is discovery. So you have to discover each other. So if you want to use like rabbitmq or maybe another service, you need something called service discovery. And with Docker Compose, you can create this link thing. So from that point on, you see on line 8 that we just can say, just use rabbitmq. And Docker Compose are smart enough to tell where that rabbitmq is running. You can see on line 27 that we use the rabbitmq basic image, which gives you a rabbitmq message queue to get started. So this is the Docker file we have. You can I put the little slide to the right side where you can see from the base and run updates. You can see what's going on. So you can see we run from Node. So we choose a 6.10 Alpine base image, which is a small image. So it's I think it's about 40 megabytes, which is quite small for a Docker image. Then we do some setup. So we create our home there and so on. Then we specify some environment variables. We copy the source code and we run npm install so that we make sure that all the packages are there. And then we copying the rest of the code. The nice thing about line 11 and 12 that we cache the packaging. So the next time you change something on the code, but you don't change your package, it won't run npm install again. So it makes changing code and building a new image more quicker. And of course, on line 17, we tell how to run this application, which is Node.js. So to run this example, first we have to build the images. So first we have to build our microservices. So we run docker compose build. You can see the output. So we use a rabbitmq, which is an image, so we don't need to build it. So it's skipping, but the other one is going to start building. And then we can start our microservices. So you can do something like docker compose up, and then everything will start, but I'll show you just step by step just to make it more clear. So you can see start backend, you can docker compose up -d rabbitmq, which starts your message queue on your box, isolated. If you stop it, it's gone, which is really nice. So you spin up your database or your message queue, play with it, delete it, and you don't have any garbage left. And you can see that we start our publisher and we start our subscriber. So we have like now 3 services running, which are running isolated from each other. The nice thing with Docker Compose is that you also can mount your local volume to your running container. This means that because Node is an interpreted language, you can just edit your code on your local machine, and that code is changed in the container. So that's nice. You don't want to do that in production, of course, but for development, you can just change your code, do a reload of your browser, and you can see your changes, which is quite nice to have. And here you can start everything together. So this is basically when we start the whole system. So we hit docker compose up -d, which is deionized, and we start the rabbitmq, and we start both of the microservices. And we can also scale it up quite easily. And with docker compose ps, you can see that the things are running. So let's talk about deploying into production with Cloud66 for Docker. So basically, what we do is normally you are, have an ID, you translate that ID into code, and you want to deploy it as fast as you can because you need some feedback from your customers and then iterate about that about your ID. But the whole thing about build, deploy, run, maintain, and scale your application, that's quite hard, especially when you don't have operations people. So Cloud66 will simplify the DevOps. So we take care of all that heavy lifting there. So in this in the Git repo, you can find this service YAML file, which is basically it looks like Docker Compose, but this is for production-ready deployment. So your service YAML is our description of services you can deploy with Cloud66. So you can see here, you can see the publisher describes the Git repo, the ports, the Docker file, and the nice thing when you deploy this application, we will build your image and deploy it on any cloud or bring your own server. And if you make some changes of the code, you can have like a webhook that tells, okay, the code is changed, let's rebuild it and deploy it again. And also because you're running microservices in containers, you can do like 0 downtime deployments, really easy. And not only for Node, but also all the other technologies you want to mix match. You see the subscriber using the same thing. And of course, we specify the database. And it's good to know that at Cloud66, there are 2 ways. You can run a database in a container, but you're on your own managing it. But we run databases and message queues, the native one, so not in containers, because then we can give you all the services like scaling, backup, and restore. So how does this work? So I'm going to show you how to set up a production environment using microservices, Node, and Docker. So here we start with an example project, example Node microservice. As you can see, you can say I built the image from a Git repo, but because we are using microservices in one Git repo, we have multiple Docker files. So we go into advanced mode. And in advanced mode, you see here, we can just specify the services using service YAML. And then we're just gonna start building it. So we're not going to deploy it yet. Which first we make sure that all the images are correct and built before you can deploy. So this is gonna build, and you can see that it's just running a Docker build. You can see the output in the UI, and now we build our images, and those images are stored in a private repo. You can access that private repo if you want, or you can bring your own images. We set a deployment, so we say we want a production environment, and of course you can see that we're going to deploy to DigitalOcean. We integrate with all the major cloud providers, or you can bring your own server if you have your own bare metal. And of course we have to specify of course which server we want to use. So DigitalOcean, we choose 2 GB, 2 CPUs, and when you hit deploy, we spin up a server for you on DigitalOcean. We make sure we install the packages, all the health checks, security, firewalling. So we make sure everything's up to date, and then we're gonna deploy the services. You can see that we're running a Docker cluster, which has 2 containers running, and a RabbitMQ server. Of course, you want to scale, especially when you have a microservice architecture, when you have multiple services doing some workload for you. Sometimes you need more capacity. Maybe your services want to, your message queue is full of work, and you want to have it doing the work much quicker, so you can scale up. And with a couple of buttons, you can just scale up and say, okay, the publisher, I want to have 10 publishers for some reason, of 4 subscribers, and then you hit scale, and then we scale up the Docker containers. And depending, of course, of how big your server is, you can scale as much as you want, and everything is load balanced automatically. And of course, when you run something in production, maybe you want some infrastructure things like SSL certificates or load balancer. You can. So for here, I'm gonna easy scale up my Docker cluster. So I have 1 server. I want 2 servers running my microservices in containers. You can. And you see the add-in, you see a load balancer there. And now you can see, here's just an example how a Docker cluster looks like with 2 servers. So we have dir and Docker host, and you can see that 1 server, there are 8 containers running, and the other one are 14 containers running. And of course, we integrate with Let's Encrypt. So if you bring your own certificate, you can pop in your own certificate. If you don't have a certificate and you want to use Let's Encrypt, which is provide you certificates for your secure connection for free, you just pop in your domain names, and we take care of all of that. So this is the end of the presentation. Thank you very much. And if you want to try out Cloud66 deploying your Node microservices, just go to Cloud66, sign up, and use Cloud66 YLD to get some $60 free credits. And of course, the GitHub URL where you find all the examples. And there's one question in the live chat. It's Sanyade. I hope I pronounce your name correctly. He's asking the question, Docker or Vagrant, what is preferred? I prefer Docker because it's much easier to set up. You just install the Docker runtime on your local machine. You prepare a Docker file, a Docker compose, and it's much faster, for one thing. You don't have to spin up a whole VM. And you can just spin up different environments really quickly. So I would say Vagrant has its place, but Docker is really, really handy tool doing microservices and quick iteration of your development. If there are any other questions, you can use the live chat. Okay, there's another question. There's a question from Radical. Can you change the load balancing mechanism of Cloud66? Like like using different load balancers rules? Yes, you can. Basically, what we do is that we, depending on your cloud provider. So if you deploying on Amazon, we using Elastic Load Balancer. But if you deploying on your own cloud, then we just spin up a small instance using hproxy, and you can change the load balancing mechanisms in what we call the manifest file. So we don't, the standard way is round robin, but you can also do sticky. And the nice thing is that our load balancers are smart enough when you have, like, for instance, version A of the service running and you want to start version B. We spin up version B of your service, wait till it's healthy, and then we switch the traffic automatically, so you get zero downtime deployment. Sanyade is asking, is there a slide or documentation that explains more in depth? So, well, I'm going to write a blog post about this webinar the next week. I will send the link to the meetup pages. So if you are signed up there, you can find a link to the blog post where you can find the YouTube video, but also some links to some interesting content explaining microservices,